a pen out for your grade homework soon?
Oh, yes, she's right. You multiply by 1/2. Yes.
Double throws. There we go. I see a lot of us that are either stuck or done attempting. There might be a few that are somewhere in between. Oh, I have no idea which one I chose. This one? It's like this one, I think. Okay. Down 3. You subtracted 3 from what values? Down 3. Subtracted 3 from the y values, the heights, right? Okay. So instead of -4, 2, it's going to be -4, -1, right? 2 minus 3 is -1. Instead of going -2, -2, where's he going to be now? -2, -5. Subtract 3. And it seems about halfway in a tick mark, right? 0, -2 will now be 0, -5. 6, 2 will now be 6, -1. Point by point, right? Now, what if in homework you guys had like parent functions that you were moving? Could you still do it point by point?
Yes.
Didn't we kind of do that in class? And then come back, but some of you are like, this was like one question in homework. What's the big deal? Didn't we do an absolute value one in class?
Yeah.
And how did I demonstrate? Oh, actually over here. How did I demonstrate doing absolute value? What did I start with? Parent function, a few key points. So couldn't you do point by point even with equations? Yeah. You just have to take the initiative. What? Oh my goodness. Life lesson, that's a good thing to do. Take the initiative, figure out what the parent function is, put a few key points, and then move them, transform them, change them, right? Because some of these parent functions, like lines, we kind of just memorize, oh, graph the intercept, graph the slope, you're done. Lines are no big deal. But with everything else, it's going to be helpful to have a few key points and then be able to transform them, okay? So coming on back, this is why we're practicing point by point. Because even with parent functions, point by point may be the easiest way to go. Okay, number next one was black. Oh. Vertical flip down 1. This one's, I think, out of all of them, the hardest. Because if you go down 1 and then vertical flip it, is that the same thing as vertical flip down 1? No. So which order do we go in? Yeah. We deal with the flip first in its original orientation, and then we do the shift. Okay, so the order is important. So vertical flip, okay, instead of -4, +2, to do a vertical flip, I multiply x or y by negative? The y. I need it to be opposite vertically, right? So it's going to be -4, -2, flipping, and then down 1, -3. The two things at once. So instead of going up 2, I'm going down 2, and then I'm going down an additional 1. Yeah? So instead of going down 2, what am I doing for the point -2, -2? Up 2, and then I go down 1. Okay. Same thing here. I go up 2, down 1 for 0, -2. And then instead of going up 2, I go down 2, down 1. And we should have our vertical flipped and then shifted down 1, approximately. I need a ruler. I have one that takes too much time. Yeah? And then last but not least, letter G, horizontal compression, y by 1/2. Just like the last thing we talked about yesterday. Because it's on the inside, right? And inside things work differently than we think. If we see x minus on the inside, we're actually going to the right, not the left. And when we have dilations, as we saw yesterday, and they're on the inside, we actually multiply that variable by a factor of 1 over that number. So instead of doubling, it's actually going to be cut in half. So then let me go get a pink real quick. Where is he? Here he is. Well, because that's what I did yesterday. Rows, whatever. Horizontal compression by 1/2. So I take each of these points and take the original. Negative 4, 2. What do I do with the x values? Multiply by 1/2. So it'll be negative 2, 2. If you think about it, take a negative 2, plug in, it'll be a negative 4, so it'll have the same y value as what used to be a negative 4. It's a little complicated, but that's what's going on. Multiply negative 2 by 1/2, that'll be negative 1. Multiply by 0 by 1/2, he stays the same. Multiply 6 by 1/2, and where am I going? And I have horizontally shrunk him, compressed him.
I thought when it's like outside, it's a horizontal flip, even though it's vertical. Like, because, you know, it's
Outside multiplied by a negative is a vertical flip, which we word in the x-axis or about the x-axis, but it's still a vertical flip. You mean for letter F? Yeah. So going back to our clues real quick, it's not this one, it was before. Remember, whenever we have on the outside, we are doing that vertical flip about the x-axis, but it's still a vertical flip that we're doing. Does that make sense? And then if it's on the inside, then we would go ahead and we'd have that horizontal flip going on. And for flips, there isn't really anything weird about it per se. And then, oh, sorry, my example is over here. When it's a shift, it's going to be backwards of what I think. When it's a dilation, horizontal on the inside, it's going to be, I'm saying backwards just to keep myself out of trouble, but backwards than we would think. It would be the reciprocal. But the flips is kind of like just it's a vertical, it's a horizontal. All right, any other quick questions? Because you guys had number 10. He was a bit intense, but number 9 was supposed to prepare you for him. Let's go check in those evens then. Okay, color pen out. We need to check the evens for section 6, right? And the evens for section 7. We didn't get to check anything yesterday. The evens for section 6 and the evens for section 7, we're doing great quick. Now, quick heads up. We already did a homework check on sections 1 through 5, right?
Yes.
Okay. Which means another one's coming on 6 through 10. We did not, meaning the TAs nor I, we did not grade based on whether or not you were grading your homework. But guess what we're going to start doing now? Yeah. I gave you 5 sections to kind of get into it, to be getting your homework attempted by the time that we start grading, etc. So I need everyone to be grading their homework in what kind of pen? Full color pencil. Colored, right? Non-black, non-gray, no highlighters. But anything else is up for grabs. Starting in section 6, you don't have to go back. We're starting right now. We're all in the same place. This is the first homework of the next homework check. And part of the components will be, it's how much you complete, whether or not you're showing work, whether you're writing your problems directions in shortened form, but whether it's clear that you're showing the problems and directions. And now it's going to be whether you're grading it. Now, what if you get nothing wrong? Awesome. Put a little -0 or something at the top. Then we know, oh, hey, colored mark. Like, hey, they looked through their homework. They were totally with us, and they just got it all right. Could you also use your colored pen if you're checking your odds the night before?
yes.
Yeah, so maybe you get all the evens right, but maybe you missed a couple things in the odds. Well, make sure that you fix that in colored pen, and then you're reminding yourself, like, oh, it didn't go so well the first time. And that's something you could look at before the next test as to mistakes that you're making.
I forgot my spiral notebook at home, and
I'm recording, so you can grade it tonight. Sound good? Here we go. Homework number 6, section 1.6. What's number 10? What's number 12? So many evens. Oh. Final. There are 2 different ways of looking at it. Point slope or slope intercept, but it should be 5 halves x minus 1 half. Or you could have written it in point slope form. And letter B, graph the intercept first, so go down at half, then go up a 1 and a 2 and a 3 and a 4 and a 5 and over 2. Oh yeah, got him. Remember, check the answer first. There's not always time to correct the work. Number next one, number 22. Wasn't he one you were able to put in your graphing calculator? Sweet. But verbally, you didn't have to. Quite the size. What transformation occurred to this little square root function? He went up and he went back. Yeah. So I had my vertical shift and my horizontal. You didn't have to write it, but anyway, good practice. Number 28. Wait, what's that thing with double brackets? Who's he again? Step function, or in a more technical term, greatest integer function. We round back on the number line, or we round down, right? So, plugging in -2, it's just 1, which, well, there's no place to round. It's already a whole number, right? It's an integer. Plugging in a half, you would have gotten, hopefully, 3.5 round down, right? Plugging in, we get 7.2 round down. Plugging in, we get -18.6 round down. Do you remember that? On the number line, -18, what's below? -19. It's okay, change it now and don't miss it on the test, right? The negative ones are the tricky ones. You still round down though. You round to the lower place on a number line, which is -19. -19. We got it? Okay, let's keep going. That didn't work. Put down the filter, and then we'll be much better. Okay. Number 40. Hey! Were you allowed to use your calculator on him? You technically didn't need to use your calculator, perhaps, because it is just small transformations of different functions. But if you did use your calculator, graphing calculator handbook, got it handed back a while ago, how do we put in piecewise functions again? Division, right? So we have the original piece, which the first one is 2x plus 1. Division. Where do we find those inequalities? Second math, I think, right? Second math. And then what do we do with a sandwiched one? Will it work if we write it just like this?
No.
We have to split it up into 2 pieces, right? Connected with an and. Number 50, you guys are already peeking at? 50 asked, hold on, double check, you should have the question right there. Does every line have an x and y intercept? Why is it false? Every one I can think of does. It's going to hit through both, right? What am I not considering? Horizontal. Only has to go through which axis? Axis, the y. And they gave some examples. So you could just say a horizontal one doesn't have to go through the x-axis because it's going to be just going parallel. And then a vertical one could be going parallel to the y-axis. Will it ever go through? No. So almost every line except for horizontal and vertical lines. They're the exception. Do you have any other evens there? Nope. Section 1.7. How many of you guys tried to fit number 10 on all one graph?
No.
Nice. I'm impressed. How many of you guys like your graphs all spread out and so they're nice and neat and perfect? Oh. All right, number 4. Just matching, right? Little 4, little 2, little 3, little 1. Number 10 I'm going to zoom in on because, I don't know, I think that's way too zoomed out, right? So hold on, let me get view. Let's do page width. Let's get rid of this silliness. Okay, I have another one on the next page. Let's go ahead and check these ones first. Remember, you were just given, I think, like a notation for it. The way I modeled in class, and you guys were working on the back of your spirals, think through what that means and then what it looks like. What that means, what it looks like. What that means, what it looks like. I'll give you a couple more seconds. Go ahead. Stay after school, just a quick heads up since you guys are just checking. I'm going to be working the volleyball games, so you can come see me at the gate, or you can come in during lunch if there's some questions that you guys need to ask us. And remember, we just finished 1-7. We have 1-8, 1-9, 1-10. We have a big old test coming next week, 1-1 to 1-10. You're gonna get your quest back today. We're gonna work on some corrections. If that grade is not what you desire, what are some things, real quick? What are some things you can do about that? Okay, we're gonna be doing some corrections to figure out what went wrong to be better prepared for the test on 1-1-to-1 time when it comes. Study. Maybe if you didn't, yeah, that's a good place to start. But some of you studied really hard and something didn't go right. What else can we do? That's a little depressing and discouraging. Not sure it's a great piece of advice. Practice more, maybe. Come in and ask my advice on the mistakes that you made and maybe your studying technique and some different improvements that I could see or ways that I could help. If you don't feel comfortable with me, you could always go to Mr. Che, who teaches as well, but he has a lot of kids in a lot of classes too. So please let me help if I can. My free period is 7th period for those of you athletes whose coaches would rather you pop in then. You can pop in and ask me questions during 7th. You can pop in and ask me during most lunches. If I'm not here, I'm usually doing senior events, so look on the senior patio. Or after school, okay? So please, please, please. It's too early to give up. It's too early to give up. So I think it's always too early to give up. Are we done with A, B, C, D, E, F? Any quick questions on the ones that you see, ones that you thought were another way and they weren't? If you have a personal question and someone else isn't asking it, feel free to come in and ask it later. Letter G. Horizontal stretch? Nah, I had a 1/3. Wait, remember, it's inside, so what do? Flip it, we're multiplying by 3, right? So all the x values got multiplied by 3. The 0 stayed the same, but 3 went to 9, 6 went to 18, -3 went to -9, -6 went to -18. It just got stretched. Number 46, you guys can already partially see. Let me let you see them a little bit better. How do you know that the parent function is square root of x? Take everything else away, right? Ignore the +1, ignore the times 3, what's left? Right? Take away the dilation, the translations, the reflection. Okay, letter B. Same thing as up above. It's a shrink, it's a compression because you have a 3 on the inside of the root. So it's horizontal by the reciprocal. And vertical shift, it's on the outside +1. How many of you guys are kind of trying to think through the outside-inside thing? And it's kind of helping. Any of you guys just come naturally? So everyone else is lost besides like 7 people. All right. Who has another way of doing it and you just kind of doing it your own way? Okay, I'll color code. Why am I saying 3 is on the inside? Because it's under the square root, right? Sorry, the inside I think is red technically. So on the inside, what word am I telling you? Study from your notes, and you should always have your notes when you do your homework, right? That's why I have them in 2 separate notebooks. You can be working on your homework, looking at your notes, having the book, of course, nearby. But if you look in your notes on the inside, multiplication, we should have gone straight to horizontal dilation, and you should have written there by 1/. So I'm not exactly sure why we're lost on that one. Maybe some of you were just being Debbie Downers and just saying we're lost when really you're not entirely. And then, why am I saying +1 is on the outside? There's no square root over it, right? And so therefore it is on the outside. It has a vertical shift because there's that addition of 1 upward because it's a +1, all of which, of course, would also be found in your notes. Okay? There is no I'm bad at math. There might be some I struggle a little bit more than others. But there is no I can't do it, okay? And if there is, come and talk to me because there might be another way of thinking about it. There's your graph and there's your function notation at the end. I think we might have a couple. One more. 58. Why was 58 hard? I thought he was hard. Was he the one that gave you a graph?
They gave you like a.
give you a graph, right? Okay, I'm not going crazy. You guys are supposed to be writing your problems down, yeah? Mm-hmm. Question. They labeled some points. Who has it for me? I see a couple of you did a great job. For letter A, what point did they give me on that graph? 416. 4, 8, 12, 16. Okay. That was one. And then the second one, what was the point you knew about that one? 4, negative 1/2. Okay. And the question you should have asked yourself, which most of you, to be honest, it's totally fine, you wouldn't have thought of doing, is instead of looking at those graphs, thinking about what they look like and who the parent function is. Does it make sense? It looks like square root of x. It's not a parabola. It's not a cubic. It's not a line. It's not an absolute value. This is the closest one we got. If you look, both of them have x values at 4. So then on the normal graph, remember a few key points. What point is on the normal parent function of root x? Plug in a 4 and you get out a what? 2. Then ask yourself the question, what happened to these graphs? Were they shifted or were they dilated? How do you know for sure? How do we know it's not a shift? Yeah, if it's shifted, it would no longer be at the origin. Both of these graphs are at the origin, so you got to think rubber band and stretching or compressing. Okay? So for the first one, 4-2 got changed how to become 416? Well, the 4 stayed the same. What happened to the y's? Y's, vertical, outside. 8. Why not 12? Because it wasn't shifted. It wasn't added. It was multiplied. So 2 times what is 16? 8. So then put an 8 on the outside and say, haha, I'm done. You did stretch by a factor of 8. How do you make the 2 into a 16? Times 8 on the outside because it's vertical to the y's. And then for the next one, what happened to 2 to make it negative 1/2? Now some of you are like, I can't do that in my head. Okay. What got multiplied by 2 to make it negative 1/2? What am I doing? Algebra. Saying 2 times some number is negative 1/2, and I put a variable. If you don't like x because he's in our equation, make him some other variable. Like, I don't know, what's one you've used in the past? A? Yeah, I've used A before. 2 times what is negative 1/2? Yeah. Divide by 2 or multiply by 1/2, you get rid of him. Multiply by 1/2. A is equal to negative 1/4. It happened to the y's once again, so it's on the outside. I just need to go ahead and multiply. Done, done, done. Hopefully I made it look easy. Maybe I didn't. Hopefully I made it look easier than some of you were thinking last night. But to make some of you feel a little bit more comforted, that was a hard one. That was definitely a hard one. All right, kiddos. We do need to get into section. I didn't get the backboard updated because I was 45 minutes late today, but go stand for your talk. I realize we might have some questions on the odds, so we might come back. To remind me to be in class tomorrow, we'll come back to our spiral section 1617 and go over a couple odds, but some of you might just need a little more time tonight. But come back tomorrow. Listen. We looked at the evens. Come back tomorrow with any questions on the odds. Because just because you have Calc Chat doesn't mean necessarily that you understand what they're saying. And to be honest, sometimes I disagree with how they're doing problems. I think it's harder, more complicated, or even maybe just flat out incorrect. So if you have any question on those odds, come with them tomorrow. I will maybe get some people up to the boards and then try to answer them for you. Here we go, section 1.8. You guys are writing down to get all set up for today. Anybody else get something out of this morning? Was that fine? It was mostly clean by the time I got there, but you guys are coming with questions on the odds if you have any remaining from 1617. We've talked about parent functions, but we have not talked about what happens when you start combining separate functions, like square root of x plus x squared, or like 5x plus 2 plus absolute value of x. So this section starts off with what else can change functions? Adding, subtracting, multiplying by constants, by coefficients, yes. However, you can also put different functions together. And the first way that we can put them together is, or are, the easier ones you guys have known forever. You can add two functions, subtract two functions, multiply two functions, or divide two functions, right? And those are arithmetic operations. Think arithmetic, it was like one of the first maths you started learning, besides just learning like the symbols. Your numbers, etc., your counting, etc. But when you started actually doing little baby equations or little baby operations, started with addition, probably went to subtraction, then multiplication, then division. Threw in fractions somewhere along there, and then just kind of took off into algebra at some point. So arithmetic, just think like the basic ones. What's shown below by adding, subtracting, multiplying, dividing isn't meant to be the hard part. But where this does get complicated is in the notation. And the notation shouldn't be crazy, you just have to learn it. Just like function notation, f of x does not mean f times x. You have to learn the notation, and so go ahead and write these down literally. Because you would not believe how confused some people get. They look at it and say that makes sense, and then they see it in their homework and they're totally lost. Why? Which side seems to make more sense, the left or the right? Yeah. This is like the doing side, right? This is like the practical side. This is the whatever, take two things and add it together side, right? Or subtract them, or multiply them, or divide them. So this side isn't meant to be hard. And your brain just naturally, hopefully, will click with this one. But what's the interesting, more complicated, more confusing side? That one. So those are all the notations. What do you think is the most common mistake? Just think in the mind of someone who might make a mistake. Maybe that's you, maybe that's someone else. It doesn't matter. What's the most common mistake when reading this? F plus g times x. It's the most common mistake. And it's understandable. You would understand if you were tutoring this poor little 7th grader who had this and you're like, oh yeah, that's rough, sorry. You've been taught parentheses are multiplication. Now they're not. Like, it's hard, right? But you have to help yourself out as well in understanding f plus g of x, not f plus g times x, and letting yourself take a little bit of time to get this connection and then be like, oh, boom, I got it, go. Okay, a couple more seconds if you're still writing. 5, 4, 3, 2. Oh, okay. We needed a couple more. I thought we were done. Okay, remember, you have your group members. Peek on theirs real quick because I think a lot of people are done. So let me keep going. So you guys, ready, set, go. You have two functions. F has been defined for you. 2x plus 1. G has been defined for you. X squared plus 2x minus 1. The directive has been given. Find f plus g of x, not times x. Do that first, then deal with the second part of the problem. Real quick, peek in your groups and see if they're doing the same thing you're doing. Maybe they're done, maybe they're not. Just see if they're doing the same thing you're doing. Okay. What does f plus g of x really mean? F of x. Make that connection. Help your poor little brain out. Then go ahead and be like, oh hey, who is f plus who is g? Now question, do I really, in this context, need to put parentheses? But when do I need to be careful with parentheses? When there's a negative, right? If you do put parentheses, that's technically probably the most proper way of going about it, but you have to get rid of those to be able to simplify. How do I get rid of parentheses when there's no negative and no number in front? Distribute 1, which means keep it the same. Just a few of you would confuse that for multiplication. Be careful. And hopefully after combining and writing it in, don't we go descending order almost always? X squared would go first, plus 4x would go second, and then we're done, yeah? Now, what was the second directive in this problem? Evaluate when x equals 3. Hence, how can I write that with notation? F plus g of 3. Now, could I go back and figure out who is f of 3 plus who is g of 3 and find all that? Yeah, I could. Or I could say, wait, I have them. Plug them in. You guys get 21? Okay. Okay, be careful. There was more than one way of doing that second part. But technically, if you did f plus g of x correctly, you could just plug it in, and be done. Now, when does combinations, or when do combinations of functions get a little more complicated? Besides notation, which is hard. When we have a quotient. So what if, we're going to take that last example, the same f, the same g, and what if I was to tell you find f over g of x, not times x, and then state its domain. Take a couple seconds to use the exact same f, the exact same g that we had on the page before. Meaning 2x plus 1 and x squared plus 2x minus 1. Don't have tons of time, so you guys tell me. How are you starting? By writing who is f over g of x. Who is that? Give me 1 second. Just helping draw the connection. It is f over g. No multiplication is going on. Then I plug in f, which I think you guys were saying. Was it 2x plus 1? Check me. Okay. And on bottom, I believe it was x squared minus? No, plus 2x. minus 1. Thank you. Huh. If I have a quotient, I have a possible domain problem in the denominator. How do I state or find the domain? Yeah. Use our clue from before, which says take that entire denominator, set it not equal to 0. Well, I need to find its zeros. How do I find its zeros? Factor? X minus 1, x minus 1. That doesn't work with the signs. X plus 1, x plus 1. That doesn't work with the signs. Uh-oh, struggle. Does this factor? How could we know for sure? Graph it and see if it hits the x-axis, or complete the square and figure out where the vertex is, or x equals negative b plus or minus square root b squared minus 4ac. Question, are there zeros? Yes. Why? Minus and negative means plus, but we'd end up with negative 2 plus or minus 2 root 2, because it's going to be the square root of 8, all over 2. Ugh. Are these happy ones? I'm not killing anything because I factored out a 2 and then canceled it. Do we have some things that x cannot equal? Yes. But are they super straightforward ones that we would know right away? Probably not. Probably not. On a test, I don't know. On homework, I think they were a little bit more straightforward if I remember correctly. Maybe I should have made up some nicer ones, but just to remind you, quadratic formula is quite helpful if factoring doesn't work. All right, we have one more big idea. We've done notation, what it looks like to have function notation for adding two functions, subtracting, multiplying, dividing. Watch out for domain. Last one, compositions. Last one, compositions. We might need to kind of do a little bit more of section 1.8 tomorrow.
So no tests?
No, you'll get your tests. But I was just saying that we might need to finish 1.8, so just try to attempt 1.8 as best you can tonight. But when it gets to compositions, you might want to slow down and just kind of wait for tomorrow. Okay? I do want to write one quick thing. Compositions. Anybody remember fog? No? It's a little hollow circle. Don't you dare fill it in. If you fill it in, it means multiplication. Keep it hollow. I know. Keep it hollow. It wasn't just an artistic element. And it means f of g of x. You had to have seen this last week. Plug. Wait. Let me explain. Plug g of x into f's x. Plug it in. Calm down. That is what I believe we'll need to take a little bit more time on tomorrow. I am passing out our formal correction sheets that we'll be using on every test and quest for the rest of the year. It is worth a grade. Listen, corrections are worth a grade. In your syllabus, I call it the portfolio category. Because I strongly value, hopefully teach you to value, finding mistakes, identifying weakness, and correcting it, so that hopefully it's no longer a weakness, or at least it's one that you know how to deal with. Are we short one? Why don't you just turn it in tomorrow? Probably you were gone when we turned it in. Okay, listen real carefully. Shh. Every time I give you a correction paper, it is going to be worth 10 points. In a category that is along with your notes, there are only 2 things in that category, corrections and notes, 10% of your grade. It's a big deal. Look at this paper. What do you have to fill out?
Missed concept.
Missed concept, that should be between 1 and 5 words. Let me give you some examples of missed concepts from this test. Midpoint, slope, zeros, graphing points, domain. Do you get missed concept? It's like a 1-2 word description. The next one is the problem number. Go in order of any problem you missed any points on. Any problem you missed any points on. Does not mean you missed all the points. These were worth 2.5 each, approximately the multiple choice. The long answer, you only had to do 2 of them, were worth 4 points each. Some of you got partial credit. Whatever problem you missed any points on. What's the next column for? Figure out how to do it right. Completely, to get the right answer and have work behind it. The last column. What went wrong? Or what did you not know how to do right? So either you can say, oh, I was so dumb, I didn't distribute my negative. Please don't use words like dumb, though. I'd rather you just say, like, oh, I didn't distribute my negative. It's a common mistake. All of us do. Okay? Something like that. Or you could say, I didn't know what to do. Some people do that for every single one. I start taking points off. Don't just tell me what was going on in that. I didn't know what to do. Oh, I wish I had remembered zeros meant set y equal to 0. Look, that's so much better, and you're actually telling yourself something you can remember. Does that make sense? Cool. You have to fill these out for every single one you miss any problems on. Can I do this? Oh, man. When I call out your name, just come and get it, and you may leave. Ashley, Haley, Yvette, Caleb, Lauren, Tyler. Haley, you coming? Caleb, you coming? Tyler, you coming? David, Nathan, Denise, Nadia. Tyler, right there. Nadia. Ricky, Mia, Jason.
That's just amazing.
Bayla's gone. Emily. Cameron.
Hey, check. Are check
Jesse.
marks good?
Check marks are great. Wait, Alex.
Yeah, 50 billion.
Mason. Jacob.
Yeah.
Maddie. Fuller. Sorry. I realized it. Naomi. Jane. Elaine. Austin. Sam. Justin is gone. Lucas. Abby. They're right at the bottom. And Abby.
How many points is that? 50?
50. The TA forgot to write it. I apologize.